there had been this Ebola crisis or that thing, etc. And they always came in and said, oh, we got the airplanes, what do you want us to do? And people say, oh, that's really great, can you get us email? And so he said they discovered that not only did people need physical stuff moved, but they also need digital stuff moved. It was actually a really big deal. And there are a lot of places where it was not plausible to get satellite equipment in, stuff like that. And so we actually went running upstairs to talk to Hank Foss, one of the physics professors, who had a background in rockets and satellites and stuff like that, and said, hey, you need to come tune into this. And so we got him talking, and so that's how Taylor Satellite #1 started, TUSat-1. It never launched because of a whole bunch of things, had nothing to do with our satellite, but the Launch Alliance blew up, so to speak, and it didn't happen. But that got us started, and so another point worth mentioning is I'm a mere mortal. I spend much of my time when I'm programming feeling really dumb because I keep making dumb little mistakes and the computer sneers at me and says, ha, for the compiler. One day, about 6 years ago, when the engineers comes back and says, okay, so this is for Taylor Satellite #3. We're going to be launching it, and then the data is going to come back via Globalstar. It's one of the big satellite things. Anybody not signed in yet? Everybody's happily signed in? Okay, great. They're going to send the data back via email. And I said, via email? And they said, yep, okay, fine. So his question was, could I grab the data out of the email and put it in the database? And the answer is, yeah, we can do that. And that's how I got involved in this. The idea that somebody like me would get to do satellites was just kind of crazy talk. And fast forward 6 years, and I've been doing satellites for 6 years, building ground station, all sorts of really cool stuff. And who'd have thought? And so the moral of the story is you folks can get involved as well. Satellites have changed radically in the last 20-some years. It used to be that, I guess it looks less dumb if I take this off. Well, these days everybody just kind of goes around, you know, it's the new jewelry look. They've gone from, you can still build a $1 billion satellite if you want to, but a lot of these things are in the hundreds of thousands of dollars, and now they actually have the things that we're working on, satellite #6, which we are roughly finished, and satellite #7. They look like a big piece of toast, kind of, just slightly thicker than normal bread cut. It's $33,500 list price for FCC licensing, the launch, data budget, big chunk of the satellite, testing, all sorts of things. That's real money. Now we got the one that you got, previous one, #6 was actually free to us. We got it from Virginia Space for free, which was really sweet of them. This one wasn't free, but because it was kind of like on the clearance rack, they had a few slots left for satellites for the launch in February, and it has to be done by the beginning of October, which doesn't give us a ton of time. So it was kind of like the shelf life was going fast. They said, okay, we need to. So I said, hey, could we get one of these at cost? And they said, sure. So it cost us $12,500, which is still real money, but that was money that was in the budget line allocated by the Taylor board for doing satellite projects and stuff like that. So what's happening is, last spring, we got COVIDed out, kind of, but we kept on working. So we started at the end of January, and we finished most of the code by sometime in April, and we're finishing up setting the chips and stuff like that. So that's almost done. Vanna White in the back there, we'll show you, no, this is Mr. Rob Cartwright, he'll show you some of the stuff there. But so this is going to be a rinse and repeat. Normally starting at the end of August and trying to be done at the beginning of October is not doable. It's not very plausible. However, it's very similar to the previous project, and the goal is not just to get this done, but to try to get a whole bunch of people who have never participated in something like this, get them to get a chance to get involved. Is that good?
Yep.
Okay.
Okay, so I have a couple other people who are going to talk a little bit today. I have Mr. Rob Cartwright in the back, who was the project manager for Satellite 6. I have James Mitchell, who actually is working for Near Space Launch at the moment, and he has a project development board that he's been working on, and I think you're probably in the final stages of that, right? And so that is an option that we might utilize to fly, and we'll talk about the reasons why we might or might not do that in a little bit. And then we have Mr. John Pugsley, who actually developed the space data dashboard. When did you do that, John?
Last three summers previous to this.
Okay, so 3 summers ago, and so really kind of a unique thing, and I'll let John talk about the space data dashboard and how it works and why it's really kind of unique. Mr. Cartwright, you want to come talk about Satellite 6, where we're at, some of the issues that we saw, and how we can avoid that?
Yeah.
You got 5 minutes. I'm counting down.
Excellent. So this is 7 right here, right? No, 6. I keep losing track actually. So many of you guys were involved with this. Raise your hand if you were involved with this one in the last 3, 4, 5 months, software-wise and everything. So I just put the rest of the circuit board together about an hour ago. It's been a real brute. One of the side things we'll talk about is that you can, I called it solder's block, like writer's block. I got halfway through this project and we set it aside in about April after you guys were writing code. And then when I went back to look at everything, it's just a mess to try and find, even though I kept all the files in order, and then the machine's got ISO, we've got a new image on it. So these are the kinds of things that happen. So it's really critical when you're developing that you keep track of the names on your files and all that kind of stuff so that you can come back to it. I mean, I had stacks of paper and everything, but it's just brutal to get back to. I kept all of my circuits in order, things like that, so that I could come back to them and look at them as well. But so we've got a propeller. I'll try to explain what each of these are, but we've got a Parallax propeller microprocessor on here. Many of you probably have seen or done with something with an Arduino before. This is a step up from that. This has 8 processors. We have a UV sensor, temperature, a light sensor, just so regular light sensor there. And then we have a inertial mass unit, which has about 6 to 9 different sensors in it. So it'll do gyro functions, it'll do acceleration, speeding up and slowing down. It'll also do temperature. There's another temperature probe inside that as well, and things like that. So, and then we have 2 resistors. And you guys aren't electronics students. You're everybody computer science, or did we wind up some hardware guys here as well, guys and gals? Excellent. Okay, good. So we're using some very low half ohm resistors, and then what's flowing through those, we're looking at the voltage across. If you remember your Ohm's law, then we can immediately figure out how much current's being used by this, because we'd like to know and track that and bring it back down to the space data dashboard so we can look at how much current as we kick things on and off. Because now we won't be able to kick it on and off by remote, but we have algorithms we're writing to trigger that. So anyway, had a lot of folks doing this over by remote. It was amazing to watch people work. So I would sit in the lab, move things around, put wires in place, and then the code was being written by remote, and even the data was being looked at by remote. So that's how we operate right now. So cool.
James, you want to talk about your...
So, I'm also working at, like they said, at Airspace Launch. Specifically, I'm using the same processor that is on this other board, but this one also has a lot of extra sensors built into it, basically a lot of things that people would generally want to use on a space launch. So we got the UV sensors, lots of temperature sensors, and the IMU like he was talking about, and there's also, you can put on a grid eye, which has it's kind of a camera with like a thermal camera that you can take pictures of the horizon to get telemetry on the satellite. And there's lots of different sensors on here, and also it has the ability so that you can put on your own sensors. So if there's stuff that isn't on there that you want to put on there, then you can solder it and include it. But the real nice thing about the Parallax processor is, like Rob was saying, it's 8 cores, or 8 separate processors going in parallel. So you can have 8 different functions going on at the same time, and they're not going to run into each other. So it's real handy for collecting lots of different data and then compiling it all and then sending it through the various systems to get it down to the data dashboard. But yeah, I've been working on this, and it's getting pretty close to being able to use, and yeah.
Okay. So where are you at with the development of the board?
Yeah, so this is version 4, and it's pretty much all the way there. There's might be a few tweaks. We're still doing a little bit of testing with sensors, but basically this is pretty close to being the final version.
Okay.
Within like a week or two, we should be able to hand it out and all that, so.
All right, so what sensors are already embedded on the board?
Yeah, so there's UVA and UVC sensor, which actually covered the whole spectrum range of UV. There's a particle detector for counting, gamma and gamma radiation, basically. There's 3 temperature sensors, the IMU unit, the thermal camera sort of horizon sensor that you can plug in the side, and that's about it on the sensors. It also has got, I put extra EEPROM on it, so that way it should be able to store word data and that sort of thing.
That's awesome.
As well. Yeah.
Okay, thank you.
Yep.
Does anybody have questions for James?
And for folks that have written code before for the other unit, SAT6, a lot of the same sensors, but they'll be at different addresses, different port numbers, but code should be rather transportable.
While John's getting in, we built this for Virginia Space for this project, for working with universities, high schools, middle schools, doing satellite stuff. Basically, it was built in this room and next door in 218 over 3 summers. Most of the work was done the first 2 summers. John started when he was actually still technically in high school, got involved in this, and so the second summer he was basically the project manager. And last summer he was mostly it. A couple of people worked with him. Anyway, so this is something that we built for them. And there's a lot of cool stuff that people like you have done. Sometimes even just freshmen, sometimes sophomores, whatever. John, you ready?
Yep.
All right.
So in general, especially during the early stages of your project, a lot of the schools are just testing locally, and they don't even need to use a website. They're just running it on the desk and looking at the data on a local computer. But once you get to the point of actually creating your flight kind of demo unit and then actually creating the satellite that launches, you get a lot more requirements on basically taking all the data you want to send and compiling it down into a very limited number of bytes. And so one of those requirements ends up being that you have that byte format of just a raw string of bytes with no identifiers on it, nothing to say that this byte is for this sensor, etc. So all that has to be set up before you launch the satellite, and then once you launch the satellite, that's it. You've configured it ahead of time, and the website you've also set up here so that once the data comes down, you get it here, and then it's translated properly. So you want to test that on the ground before you actually get it up in the air where you can't change it. So we show basically all of the sensor data that comes back, especially anything numeric. It's a very flexible site in terms of if you have some custom sensor or some new thing we haven't seen before, you can still set it up yourself on the site, and it'll translate it for you and show it in graphs. We've got mapping, some other stuff. The other aspect of this is that what you'll be doing is part of a program that a lot of other middle schools and high schools and universities are all participating in. So even though you may not be directly interacting with most of those, they'll still be on here. You'll be able to look at their data, they'll be able to look at your data. There's kind of discussion forums, there's places to post reports of things you've done or look at reports that other teams have posted, etc. So all of that's available. And then one of the things you'll interact with most specifically, like I said, is the editing the actual packet format. So you've basically got a whole bunch of bytes here in a row, and you go through each one. You name it. You'll tell it how many bytes it is, what the data type is, if there's some conversion formula that the site needs to use to modify it in any way, etc. So that'll kind of be the home page for a while as you're actually developing the byte format of your packet. So it's a rough overview of the site. So, any questions about that?
The launch is currently targeted, last figure I saw was February 1st. But something that we've learned is these things launch when they launch and not a moment before. Sometimes you get to within 2 hours and some sensor goes kaflooey and they scrub the launch. Or even before that, they were going to launch something and there's something else that's higher priority. And anyway, so target is February-ish. We will see what actually happens.
Okay. All right, so what's next? So Mr. Cartwright is actually finishing up satellite number 6. We've got satellite number 7 that, was just kind of a blessing that came out of the blue. It was an opportunity, and Dr. Brandel was able to secure that for Taylor University and us. And so, great opportunity. So we have some options, all right? Because of the short time frame, we're not going to be able to create a whole lot of new stuff, okay? We're not going to be able to recreate the wheel. But we have the James Mitchell board, the JM board. Hopefully that's what you named it. All right, which has some advantages in that one of the largest killers of time on this last one has been creation of the board. All right, because we went with a custom board, and we're still struggling with that, trying to get that. Actually, just finished it today, but it ate up a lot of time. And when I say a lot of time, I mean a lot of time. Now, thankfully, the students were able to still continue working on programming through that, but we haven't been able to send the project downrange yet. All right. So we have the Parallax board, which is an Arduino-based board. Am I right in that?
Huh?
Yeah.
No. Parallax board is Parallax processor.
Yeah, Parallax uses the blocky props, which doesn't work. Doesn't work for most of the sensors. And then we have the Twigs board. And so we have some options. And we've got some people that have been around for a cycle or two. John Pugsley has said that he'll be willing to help us out if we get in a bind and kind of put us on the right way, because he's been involved in several of these projects now. And then we also have, did Jeff do it here? All right, there he is. So you did a lot of heavy lifting last time on the last one. All right, and then I think Michael Toth, is he here? Yeah. Okay. And so we've got some people with some experience. And so what we're looking at is we want to do, we want to put another satellite in orbit, obviously, and we want to do that with a minimum of fuss and muss. All right, and so as Dr. Brandel said, this is almost a rinse and repeat. It doesn't necessarily have to be a rinse and repeat, but we can take data from the last one and we can basically leapfrog right off of that, all right, and take some of the code that's already been written for some of these sensors, and we can move on. And so we can save a lot of time and a lot of effort and a lot of fuss by doing that, all right. So what we need to do is, identify people who are interested in doing this. This is an informational meeting, and so maybe some people showed up and they're not really sure this is something they want to do. All right, I would encourage anybody who's here that this is an opportunity to learn. Even if you have no coding background, you know nothing about satellites, all right, you still can be a productive member of this team, and you can learn. And the more that you learn, hopefully we're going to continue to do these satellite missions. And so there will be continued opportunities to continue to grow and learn and do this kind of stuff. All right. And so we need to work on teams. We need to figure out who's doing what. We need to identify the sensors to fly. And so we can look at, and we can do this in a separate meeting, but we can look at the sensors that we did on satellite 6 and say, you know, of that, is there anything that we would do differently? And I have one thing that I'm thinking that I would like to do differently because we have an EEPROM on that board, so that would be awesome. And then, you know, are there other things that we could do that you as a group, you say, oh, I've got this awesome idea that we could research, all right, and to look at that and say, is it feasible to do? And it might be, it might not. And if it's not for this one, that doesn't mean that we can't do it in a follow-on session. Does that make sense to everybody? Okay. And so that's kind of where we're at. What questions do you have, if any? Yes?
What is the purpose of this satellite?
Well, that's a great question, and that's kind of why we're here, because the last satellite we were developing it really to look at how the satellite performed after it broke loose, whether it tumbled, because on a previous satellite we had issues with data transmission, and what they theorized is that it's because the satellite was tumbling, and so that satellite was geared more towards that. And Rob, you feel free to jump in.
Yeah, he's exactly right. So we're detecting that with the IMU and the rotation, but then also because of the new Parallax processor, looking at what it's like to run something that's in the 80 microamps, I think. I run the numbers off the top of my head, but the Arduino is orders of magnitude higher in using up power, and it only has one processor in it. So those were two changes that we were.
And the Parallax board has not been flown in space before.
Yes, yeah.
All right, and so that was one of the reasons why we were really looking at the Parallax board, and then the JM board has not been flown in space, and so there's a lot to be said for that. Now the downside of that is that it might be a colossal failure. I'm sure it's not going to be, but you know, there's always that chance that, you know, there's some inherent flaw that we can't overcome. All right, and so the goal of this is for the students to gain experience, to put another satellite in space. Ideally, I think that we would like to fly the JM board, but I think that it would be prudent to run concurrent development with the Parallax board as well, so that if we have an unforeseen failure, that we can still launch. All right, and so what we're going to research, so ideally we're probably going to pull some of the same sensor code that we used on satellite number 6, but that's not to say that we can't add in a few other things. Maybe one other thing, maybe two, I don't know. Yes, sir.
So if I'm hearing you correctly, the goal is to use the jam board, but if that doesn't work, we're going to fall back to the Parallax board.
Right, we're going to do concurrent development of Parallax and a JM, and since they're both the same processor, right?
Yeah.
So actually, all the code should be transferable. All right. The upside to the JM board is that there are sensors that are already embedded, and so we're going to have minimal soldering and bridging and daughter boards and all that good stuff, which is what really killed us on this last one. Does that answer your question?
And the Parallax board was on satellite 6? Or
Yes, yes. Other questions?
The one in April 2019 was an Arduino, and that was Sat5. Would that be correct? Yeah. And they, most of the time outside of here, you'll hear them. It'll be flight NG17, NG14. So we flew on NG14, which is Northrop Grumman 14. That's what NASA and other people at Virginia Space call it. There's a lot of names, and at some point we'll try to get you like a syllabus, or not syllabus, we call it encyclopedia or whatever, of just
The glossary of terms.
Yeah, glossary, thank you. Just a glossary of terms, because otherwise you get hit by this entourage of data, all these names, and you're like, I can't keep track of it all. And but you know, you guys will learn to use acronyms. You already do that, and you know, as you're also talking, you know, this is great stuff to go into an interview with. I mean, you know, things like this that I've been involved with from young until old. You go in there and you talk about satellite, they look at that and they go, oh yeah, okay, you did a satellite, that's got to be crazy. You really did do that, did you? Well, when you start talking and you're actually able to give viable things about TRLs and apogee and blah, blah, then, you know, you're at Rockwell in an interview, they're like, oh, he really knows, he and she knows about satellite stuff, you know, and so now you're suddenly an expert. Because you'll be an expert on a bunch of stuff. And you'll hear about, you know, where we're being placed into space and where we're going to come out and what the second stage deployment is on the rocket. And these are just all things that in interviews you suddenly you go to an internship or you're in a practicum and you're talking with the best of them because you have a whole story to give, and you know, over lunch even, and suddenly you're a viable part of the team. So.
Right. Yeah, so I mean, this is a wonderful opportunity. You know, like I said, and even if you have no experience, I'm not a coder. All right. I'm also not an electronics guy, but I've done a heck of a lot of project management. I'm 27-year military guy. All right. Rob is an electrical guy. And so we're going to take our strengths as a group and we're going to launch a satellite. Are there any other questions? No other questions? Does the Tuesday, Thursday time frame work for people? Is there anybody that doesn't?
Can you be more specific? What times on those days?
Say again?
What times on those days?
I mean, 5, 6. Does 5 work for you?
Like an hour, like maybe 5 time slots.
Oh, the working groups will probably work longer. But again, you know, this isn't, everybody has a busy schedule. Right? Everybody does. And so you give what you can. All right? So if you can commit to an hour, then commit to an hour. All right? Come, learn, be a part of it. All right? And we'll do what we can. All right? Nobody's going to be chasing you around saying, "Oh, you didn't show up to the meeting." All right? That's not what this is about. This is an opportunity for all of us to join together and to do something that's really, truly unique. All right. So let's meet again Thursday at 5, and we'll start breaking up into working groups. And we actually do have some controller boards that we purchased with some grant money this year. And so we can actually start doing some programming right off the whip stitch. And so we'll be leaning heavily on our folks that have been involved before. And ideally, the goal of this is for the folks who have participated in previous satellite missions to kind of take a step back and help mentor the new people, all right? Because you learn your best when you're actually stuck in it and saying, man, how do I do this? Why isn't it working? All right? And then, you know, they're going to help us kind of guide things in so that we're able to get this done. All right, does anybody else have any other questions? Dr. Brandley, you want to add anything?
Very quickly. So if you're saying, I know nothing about this, I don't belong, that the answer is no, all wrong. Even if you know nothing and are convinced you know nothing, if you're interested, just show up. Being interested is sufficient. Come, watch, learn, ask questions, that's fine. And you have to start somewhere. So please just show up and we'll get you going on something. Exactly what's going to fly, we don't yet know. But the risk is if we're to, you know, James is a great guy and he says he will have it done in a week, probably, but he doesn't control things.
Yeah.
Something might go wrong that's beyond his control and suddenly we'd be high and dry, so we're actually going to have a plan B just in case, maybe even a plan C. And so hopefully be the opportunity for everybody to get somewhat involved. And it's just, I mean, if you'd asked me when I was in high school, do you think you'll ever get to help build satellites and satellite communication? Yes. Me? Yes, you guys get to get involved. So show up if you're interested.
Well said. All right, folks, thank you. And we will see you. I'll send out some more information to the emails that you provided. And then if you have questions, you can email me, drop by my office. You can catch Mr. Cartwright, Dr. Brandel as well. All right, looking forward to it.